All right, welcome to the first day of Math C, Unit 2. We're going to start off this unit by talking about some points, lines, and planes. So before we start talking about that, we need to talk about a couple forms that we've seen before. The general form of a line, which is AX plus BY, is C, where A and B are constants and X and Y are the normal X and Y's we're used to seeing. My slope-intercept form, and that is where y is equal to mx plus b. And in that formula, my slope is the m, and my y-intercept is b. Now my slope tells me how I rise over my run, and my y-intercept is where I first plot my first point when graphing. Okay, so we're going to take a look at how to change a general form into slope-intercept form. So if you recall from the slide before, slope-intercept form was y is equal to mx plus b. So my goal is to get the y value by itself. In this first example, we're going to go ahead and subtract over that 3x to both sides. So I get 6y is equal to negative 3x plus 9. Next, just like as if I were solving any other equation, divide everything by 6. That results in my y by myself. But when we have multiple terms being divided by the same number, we're going to split everything and divide it. So I have negative 3 over 6x plus 9 over 6. When I reduce those fractions down, I get negative 1/2 x plus 3 over 2. If I divide both the top and the bottom by 2, I result in 3 over 2. And that is my slope-intercept form based on the general form above. Okay, let's try it with the second one. We know practice makes perfect. We want to get y by itself. So first I have to get rid of that 5x. Now notice, there's that negative sign with that 4y. We cannot drop that or else it'll change my problem completely. So then we get negative 4y is equal to negative 5x plus 8. We're going to go ahead and divide everything by negative 4. This results in my y by itself. Negative over negative will turn positive, so then I get 5 over 4x. Positive over negative will turn negative, so I get 8 over 4. Go ahead and reduce that last fraction. I get y is equal to 5 over 4x minus 2. So not probably something we've seen before, nothing too difficult, just going ahead and manipulating my variables. Now we're going to learn how to graph with a pencil. If you notice, these are the exact same equations as the one on the slide before. So we had y was equal to negative 1/2 x, negative 1/2 x plus 3 over 2. Now 3 over 2 is just 1 and 1/2, or 1.5. We talked about on that first slide as my last term, or that b, was what's called my y-intercept. Now we've seen graphing before. This is just a nice little refresher. We know that I'm going to start at my 0, 0, that's where my origin, and I'm going to go up 1.5, so it's about there. And then I'm going to go ahead and use my slope of negative 1, 2, which means I'm going to go down 1 to the right 2. I'm going to put a dot. Down 1 to the right 2. I'm going to put a dot. Now I want my line to be nice and even, so I'm going to go back to my original intercept. I'm going to do the opposite. So I'm going to go up 1 to the left 2. Up 1 to the left 2. Then I can go ahead and connect my dots. And there's my graph. Okay, same idea. My equation from the slide before was y was equal to 5 over 4x minus 2. We're going to go ahead and start at negative 2, because that's where my intercept is. It's down 2. And then from there, I'm going to go up 5 over 4. So I'm gonna, because this one is positive, I'm going to go up, not down. So switch colors again, up 5, so 1, 2, 3, 4, 5, to the right 4. 1, 2, 3, 4. One more time. 1, 2, 3, 4, 5. To the right 4. 1, 2, 3, 4. And I'm just going to do 1 point going down. So go back to my original red dot. Down 5. 1, 2, 3, 4. To the left 4. 1, 2, 3, 4. Then we're going to make that nice line so we can all see it. And yes, I understand that the directions say with a pencil, but I don't have a pencil on me. So again, go ahead and feel free to pause whenever you need to. Next, we're going to learn how to use your calculator. So if you do not have your graphing calculator with you, you need to pause the video and go get it. Okay, we're going to go ahead and graph the equation that's up here on the right. We want to graph y is equal to 2x plus 3. So what we're going to do is we're going to turn on our calculator. That's the little on button down at the bottom. Go to the y equals button up at the top. It's kind of off to the left. You're going to hit, you already have it in y-intercept form. So you're going to hit 2, the x button, which is kind of over up by the top. It's going to see x, t, n, comma. Then you're going to hit plus 3. Now you're going to look at the top again, the gray buttons. You're going to look for the word zoom. You're going to hit 6 because you want to see standard, and then it's going to go ahead and make a nice graph for you. You should see you have an intercept at about positive 3, so 3 up from my origin, or 0, 0, and then a kind of steady steep slope going to the right, so up to over 1. So now you know how to graph in your calculators. So we're going to take a look at horizontal and vertical lines. Horizontal, if you recall, means that we're going to the left and the right. So example, my purple line. That is an example, however, of a horizontal line. Horizontal lines will always be y equals some value, or whatever the graph is. So in this case, I notice that I'm at 1, 2, 3 up. So I have the line y is equal to 3. Conversely, vertical lines will be x equals a value, because that's where x is always that number. So say we have this one. That line is x is equal to 3. X will always be that value. Something we've talked about, but just refreshing our memories. Okay, next we're going to sketch the horizontal line through 6, 2, and the vertical line through 3, negative 4. We're asked what the intersection of these lines, so we're going to look for a point, I would assume, and then what the equations are. So let's go back a step. Let's go ahead and look for 6, 2. So you're going to go to the right, 6, up 2. So 1, 2, 3, 4, 5, 6, up 2, right here. So we want a horizontal line through that point. So that means my line is going to be right there. Because horizontal is kind of like the sky, it goes across. Next, I'm going to go ahead and look at the vertical line through 3, negative 4. So again, start back at 0, go to the right 3, 1, 2, 3, down 4. 1, 2, 3, 4. There's my dot. I want it vertical, so we're going to go up and down. Excellent. So first we're asked what my intersection point is. So where is this dot on my graph? Correct. My intersection point is at 3, 2. Notice something about my points that I used. See anything in common with those numbers? Well, when you're given a horizontal line, which remember we said horizontal lines are my y equals, that's going to be whatever the y equals is of that point. So we were told through 6, 2, right? So my 2 is what my y is going to be equal to. Likewise, when I'm told a vertical line, and I know vertical is x equals, I'm going to use my x coordinates. And in this case which in this case was 3. And that is how I get the 0.32, because it's just my my x equals, comma, my y equals. Hint, you might have a homework question with that. Something we've also seen before is elimination. The whole point of elimination is to try and get rid of either my x terms or my y terms at one time. I like to look at what I think would be the easiest. Well, when I look for eliminations, my 2 big things that I look for is 1 plus 1 minus of the same value. And then can I get to easy numbers? Or easy multiplication. So if I'm looking back here at my equations, I've got 2x and 5y and 3x and 4y. If I wanted to eliminate my y's, I'd have to get a common number of 20, because 5 times 4 is 20, 4 times 5 is 20. There's no other number in between. Well, that's going to be a little bit of a quite large number. You could do it, but it's going to be quite large. And then you could make more errors. Well, if I look back at my x's, I have 2x and 3x. Their common number is 6. Now I can multiply by smaller numbers if possible, and so I'm going to go ahead and do that. Now I want 1 plus 1 minus. I see that I have both pluses. So that means I'm going to have to multiply one of them by a negative. Well, I know the top equation I have to multiply by 3. That means it's going to make some of my other numbers larger. I don't want bigger large numbers. I'm trying to think smarter, not harder. So I want to make my smaller number negative in order to hopefully result in positives and I don't have to worry about signs. So when I multiply that first equation out, I have 3 times 2, which gives me 6, plus 3 times 5, which is 15, times 3 times 10, which is 30. When I multiply that second equation by -2, remember everything's getting multiplied by a -2. So 3 times -2 is -6. 4 times 2 is -8. And 12 times -2 is -24. Notice how I have now larger positive numbers and smaller negatives. That's what the goal was. So try and help keep the sign issues not a problem. Okay, so then I see 6x minus 6x, which gives me 0. 15 minus 8 will give me 7y. And then 30 minus 24 will give me a positive 6. Okay, now we're getting closer. We just want y by itself, so divide everything by 7. So then that gives me 6.77777777, or y is equal to 6 over 7. We're going to leave it as a fraction for now because of the fact that rounding will make my life a little bit more tricky, but I promise you I can show you how to plug it all into your calculator. So now that we have our y value, we need our x value. So in order to find the x value, we're going to plug y back in. So instead of plugging y in, I'm going to plug 6 over 7 for y. So again, I want to use an easier one. I'm probably going to use the second one. It's going to result in smaller numbers. So I have 3x plus 4 times 6 over 7 will be 12. So grab your graphing calculators out real quick. I can show you how to easily plug this in all in one step. Go ahead and pause if you haven't done so already. So first things first is I'm going to multiply 4 parentheses 6 division 7, because that's what 6 over 7 is. It's a fraction. So I'm going to hit that divide button, and I want to put in the parentheses like I see them. So it's going to give me a weird decimal. Okay, so I know I need to eventually move this part over with my 12. So normally solving equations, I would take 12 minus that number. So you're going to hit now 12 minus your second key, which is up towards the top, right under the y equals button. and then you're going to look for your negative sign because underneath it says A and S. So what that means is answer. So you're going to take 12 minus that weird number you just got, that weird decimal. You're going to get another number. So now you're left with 3x equals that weird number, right? So typically what you would do now is divide both sides by 3 to get x by itself. So then just go ahead and hit divide by 3. Now you get this crazy weird decimal. Well, if you look back up here, we had my y being a fraction. So I want my x to be a fraction. So now what you're going to do is you're going to hit your math button. It says M-A-T-H, it says math right there. Hit that button. You're going to see a menu. You're going to want to go ahead and hit the first one. So you're going to hit math, then enter, enter. Do you all see 20 over 7? That's that weird decimal now as a fraction, excuse me. So my final answer is going to be 20 over 7. Oops, didn't want to change colors, comma 6 over 7. All right, let's take a look at the next problem. So I'm telling you already that we're going to have no solution, but I want to show you how we get to that no solution. So we're going to start this problem just like we started the last one. We want to go ahead and eliminate one value to go ahead and do our simple solving. So we started by looking at what's going to be the easiest to get to. Do we want to multiply my x's? Do we want to multiply my y's? Well, I notice if I take a look at my x, 3 times 2 gives me 4. Excuse me, 3 times 2 gives me 6. If I look at my y's, I know that 2 times 2 gives me 4. So basically, if I multiply the second equation by a negative 2, because remember we want 1 plus 1 minus, I think something weird is going to happen. So we're going to leave this first one alone. We're going to multiply the second one by negative 2. So I get negative 6x minus 4y is equal to negative 2. Well, my x's cancel, my y's cancel, so I basically get 0 because when everything cancels it just goes down to 0. And I get 0 equals 6. Wait a minute. Is 0 equal to 6? No, it's not. So when you get something that is an untrue statement, so 0 equals 6, 7 equals 20, something that is not logical, your answer is going to be no solution. All right, last problem, maybe. Again, I'm telling you in this one we're going to have infinitely many solutions, but we want to talk about why. So if you take a look, same idea. 3 to 6 multiplied by 2, 2 to 4 multiplied by 2, 4 to 8 multiplied by 2. So we're going to multiply the second one times negative 2 again. So top one doesn't change. I get negative 6x minus 4y equals negative 8. Well, then I get cancel, cancel, which gives me 0. But then I get cancel over here as well. And then I get 0 is equal to 0. Well, is 0 equal to 0? It is. It's what's called a true statement. Something that is logical. 0 being 0. 4 is 4. 6 is 6. If it makes sense, if it is a true statement, your answer will be infinitely many solutions. All right, that's all I got for you. See you tomorrow.